So we're going to review how to factor quadratic trinomial. Quadratic means the highest power is 2, and trinomial means that the polynomial has 3 terms. The name of the game here is to think of two numbers that multiply to the last term but add to the middle term. So we want them to multiply to negative 24 but add to negative 5. So we want to start thinking about the factors of 24. Well, the factors of 24, 1 and 24, 2 and 12, 3 and 4, 8 and 3. So let's go to our polynomial here, our factorization part here, and we want the product to be negative. So we can pretty much figure out that, well, in order to get a negative number, one of them is going to have to be positive, and one of them will have to be negative. The reason is because a negative times a positive is a negative. And you know that a positive times a positive is a positive, and a negative times a negative is a positive. So we have to go with positive and negative. So when we think about the factors, well, let's try some wrong ones. Let's try 2 and 12. 2 times negative 12 is negative 24. 2 plus negative 12 is negative 10. So negative 10 is not negative 5, so we'll have to try something different. What about 8 and 3? 8 times negative 8 times positive 3 is negative 24. Negative 8 plus 3 is negative 5. So these do add to negative 5 and multiply to negative 24. So we found the correct factorization. Let's think about two numbers that multiply to 12 and add to 7. Well, these are all positive, so we know our factorization is going to be positive. And it's pretty easy to think of two numbers that multiply to 12 and add to 7. Now, if you multiplied these two binomials out, you would come up with this. Here's another example. Here we want the two numbers to multiply to negative 12, but add to negative 1. There's a little 1 here. We could write a 1 here. Traditionally, we don't. So 3 and 4 are the correct numbers, and we want negative 1, so we're going to have to do positive 3 and negative 4 because those add to negative 1. Okay, well, this looks like a different problem, but it's not. We just have to add in 0x. Now we want two numbers that are multiplied to negative 25 and add to 0. If we sit around and think about this for a while, we will figure out that they have to be the additive inverses, and they will be the same number. with different signs. Okay, positive 5 and negative 5 add up to 0. All right, if you do enough of these problems, you will figure out that whenever you have a perfect square like 9, 16, 25, 36, 49, that the factorization will always look like the square root of whatever that perfect square was, plus or minus. It's called the difference of squares. All right, this one also looks like a different problem, but it's the same problem. When we have a number that's not 1 in front of the quadratic term, it can complicate the problem. So we'll look for a common factor. Here 2 is a common factor of 2, 6, and 8. So I'm going to factor that out. Okay, this is allowed algebraically because 2 times 1 is 2, 2 times negative 3 is negative 6, 2 times negative 4 is negative 8, and so on. So I'm going to leave that 2 here, and now we're going to factor, we need two numbers that multiply to negative 4 and add to negative 3. So they're going to add, they're going to multiply to negative 4, and they're going to add up to negative 3. Okay, well, negative 4 and positive 1 multiply to negative 4 and add to negative 3. So negative 4, oops. Okay, so we've correctly factored this polynomial, even though it looked a little complicated. Now soon we'll learn what the utility of factoring quadratics is. We can use it to solve quadratic equations sometimes. Now, not all quadratic expressions are factorable, which is why we will cover the quadratic formula, which is a general solution.